going to present two very useful techniques for you to refactor untested code. You know, that kind of code that you are afraid to break because nothing is telling you if you do so. I personally have been following Philippe for years, and I always appreciate his content, his advice. So please welcome Philippe virtually. And Philippe, you're up.
Hello, everyone. So before I start, I'll just get you to see what I'm at about. Have you been in this situation where at your daily stand-up, you're starting the day telling everyone, oh, I'm still on this refactoring and it should be over today, and next day comes and you still have the same message to deliver at the stand-up, and it lasts for 1 week or 2 weeks, and it's getting more and more difficult to get out of this tricky situation. Today, I'm going to present you 2 techniques to avoid this trap and to be able to do your refactoring safely with less risks. And these techniques will be the Golden Master and the Mikado Method. So before we dive into the code, just a quick word about myself. So my name is Philippe Bourgau. I'm a technical coach. I currently work at Murex. I'm also a blogger, and you can follow me on my blog, philippe.bourgau.net, or on Twitter as well. A very quick word about my employer. So it's Murex. We're building financial software for large organizations. We're more than 500 developers all around the world, and as well, you can follow us on the social media. So that done, let's dive into the code, as I just said. So today, I'm going to present these techniques through live coding on a GitHub repo that's famous for legacy katas. It's called the Treeview repo. So it's small enough to be able to get around it in practice, but messy enough to feel like real legacy code. It encodes the rules of a trivia game, a bit like Trivial Pursuit. So it tells you whose turn is it to play, it counts the points, it tells you who won, and so on. So if we have a look at the code right now, let's see what it looks like. So a good entry point so you see it's not too big, we've got only these few files. The code, the live coding I'm going to do is going to be in C++, but the techniques apply to any language. So the starting point here, for example, the main is you create a game class, a game object, sorry, then you add some players, and then you simulate a dice with a random, and so some player rolls the dice, and then we simulate a good or bad answer from a player, and we tell the game if he answered correctly, badly, and we continue until there's a winner. So if we dive a bit further into the game, we see, so here's the game class. You see there's a lot of fields. Indentation is awful. Some things are public, some are private. It's not easy to see which ones. And if you look into the game class itself, you can see that there's a lot of messy code. Looks like there's some prints here and there. There's some, a lot of constants in the code. There might be some duplication in all this. Yeah, there is some duplication, obviously. So it's messy, it's hairy. And today we're going to try to change something in this. So first thing we can do before we start anything is to run this and see what happens. So if you run this, you get a kind of a trace of this sample game. So you see that a player was added. This is where he is, and so another player is added, and so on. So yeah, sorry, I'm going to close this. And if we look, the goal today will be to do a small refactoring. So what we're going to look at is this add player. You see here that when you add a player, you're first adding the name, then you're setting up a place, you're setting up purses, which might be like money or points or something like that. and then you're setting an in penalty box to false. If we look at these arrays here in the game definition, you see that you've got a vector of player, and then you've got primitive arrays of places, persons, and penalty box. This array vector of player is just a string, so it's for the name. And what we see here is that this is not really nice code, because these arrays can get out of sync on all this kind of stuff. And it would be a lot better if we managed to have a vector of player, and player being an object by a class by itself. And this is what we're going to try to do today. The only thing is that I don't like changing code without tests. And so this is why we're going to use the golden master testing technique. So you can find this technique under different names, like approvals testing or characterization testing. These are all synonyms for the same thing. The idea here is to rely on logs and traces to create quickly an end-to-end test. So it's more, I mean, end-to-end, it doesn't need to be the full application, but at least it's greater than a typical unit test. And as it relies on logs and traces, what we do with this is that we capture these logs and traces from the program. We kind of store these somewhere in a reference, in a snapshot. And then we verify that whenever we change something, we don't change this trace snapshot. So it's really about refactoring in Martin Fowler's strict definition, which is changing the design of the code without changing the behavior. The problem, I think you guess, when you try to rely on logs and traces, is that these tests are very difficult to maintain, because whenever you're going to change something that you want to change in the code, all the tests are going to break. So this is why these tests are typically short-lived, meaning that you want to refactor something, so you start to put in place your golden master test. You rely on the logs and the trace to make sure you're not changing any behavior. And once you're done with your refactoring, you dump your test. And we usually use this as a first step, because it gives you some confidence to refactor your code in a better design that is easier to test, or that is more welcoming of new features that these you're going to test. And this is what we're going to do right now. So you might have guessed, but when I ran this, you saw that there was a full trace of this sample game. And this is the trace we're going to use to capture and to make sure we're not changing the behavior of the test, of the program, sorry. So if you look, that I prepared something called text tests. So text test, it relies on a snapshot here. And what it does is that what I'd like to do, I'd like to call the main, giving it an output stream to capture what's happening in the main, and then use this library called approvals to verify that it didn't change. So I can't do this right now because, as you know, the main doesn't have this signature. So what I'm going to do instead is I'm going to start by a bit of very careful refactoring to put this test in place. At the end, I'll present you other slight advantages or techniques you can do to make this a bit slightly more risky refactoring easier. So as you see here, we're using cout all the way to print things. So cout is the standard output. What we're going to do is we're going to first capture this as a field in the class. So I'm going to create here private. Sorry. So I'm capturing this as a field. Okay, so I've got an out field. So I already included this, so that's fine. What I'm going to do is I'm going to initialize this out with std cout. And to make this refactoring, even if it's a bit more risky than the rest, in order to make it as safe as possible, I'm going to go through extra baby steps and use running the system as a kind of smoke test. So here I've got my out. And what I'm going to do is I'm going to replace these C out with my out. So I'm going to replace this one, this one, this one, this one. I could replace all of them, but as I'm still in a kind of risky change here, I prefer to go through all of these. Here we go. And so next step, I run my smoke test and I make sure that nothing changed. So in C++, there's actually a way to capture the output of the standard output in a more low-level way, but I think it's interesting for the purpose of the talk to go through this step-by-step refactoring. So now that I've got this as a field, next step would be to do to extract this as a constructor argument. That's what I'm going to do. And sorry, I'm going to take all this. So, and obviously, if you're using something like Java, which has more automated refactoring tools, it's going to be easier to do these first steps. So here I changed something. I'm going to rely on the compiler to tell me exactly where I need to change something. So here we are. We've got something here. std cout. I'm just repeating what was used before. I've got this one, and I must have one here which for this sample test that we're not really going to keep for long. So now I can run my smoke test again, make sure things are still output the same way. It seems so that's fine. So I'm getting better at it. What I would like is to have a main with an argument. So I can't really have that, but what I can do is extract a method or a function called run, for example, and have main call this run. So that's exactly what I'm going to do. I'm going to just cut and paste because actually when you're refactoring, the more you cut and paste and the less sorry, so std o stream out, and the less typos you make. This is out, and here I'm going to call run. I can even return run. That's it, and let's run this. So we're still printing things. So here we are. So now if I go back to my text test here, and I should be able to call run here. So run is not visible yet because it's in this file. What I'm going to do is I'm going to add a header file. So this is these are the game runner.h. Game runner h. So these are the archons of C++. But basically what I'm going to do now is I'm going to define this one in the header file. I'll have to include some things. That's it. And now we should be able to call our run function. Before I run this, I want to make sure that I didn't. So yeah, it looks fine. So now I'd like to run this test, but my current main is this. So I'm just first going to run my smoke test, and then for the rest of the presentation, I'll switch to more to test instead of a real application. So I'll just comment the main. thing seems to be working as expected. So I'll just comment this out and define a main through approvals tests. So here I'm using the approvals test library. So what I'm doing is I'm running my app, giving it an output stream, and checking out that this output stream contains the thing I snapshotted before. So let's see how this works. So first I'm building, making sure that my tests are okay. They are, and the test should appear here in the test runner. And let's run them. So for the moment, I didn't approve anything, but here's what's happening. So approvals CPP library tells me, so this is what the actual output that was received, and this is what you approved previously. It's empty because I never approved anything. So using the diff tool, I can just approve everything as my current snapshot, save the output, and it tells me that my text test failed. And I'm going to run it again. This time it should be green. Great, it's green. What we can see, you might have noticed that there were some random things in this run. So it works now because by default it's always using the same seed. But if you wanted to do this in real life, you would have to make sure the seed is the same whenever you run your test. Otherwise, you'll have differences in the output. So we're done with the golden master technique. We've put in place the test, and yeah, something I didn't do. Yes, it's just to make sure that that I'm not telling silly things. Suppose here I put different from 1, and I run my tests. It should fail. Here we are. So we see there's differences. And this time I don't want to prove this because I made an explicit mistake, but I can run the test again and get back to green. So the takeaways from the golden master. The first thing to notice is that it works on any side effects. So it can be traces, logs, but it can also be messages, network messages, for example. And you can even add your own traces. You can use your toString or dump methods as well to create your own traces. So that there's many ways to capture what's happening. As I said before, it implies a strict separation between refactoring and adding a feature. So if in the middle of your refactoring, you want to add a feature, because most of the time we're actually willing to add features at some point, you need to be very careful when you upgrade your snapshot. So you can see that libraries like approvals CPP will help you to make this easier, but otherwise you might just deactivate your test, do your feature, and then reactivate your test. There are many different ways to do this. These tests are very, very difficult to maintain, so they're not suitable for pipeline tests. It's not a good idea to put them in your CI. But you can still keep the code to run the test and generate the snapshot. So you can disable your test, not run it most of the time, but run it whenever you need to do some refactoring in this area of the code. And it's time to jump to, how do I move this away? Here we go. It's time to jump to the Mikado method. So now that we've got our test in place, we want to do the refactoring. As I promised at the beginning, I'll give you some techniques to do this refactoring step by step without falling into a long-term tunnel where you can't commit anything meanwhile. So the Mikado method is a graphical technique where you start with a goal and you draw a graph with every prerequisite you need in order to do this final goal. And you recurse. You recurse until you get to the leaves that you can actually do. And whenever you can do one of these leaves or node, you can commit it, test it, integrate it, deploy it all the way to production. And that's the really great thing about it. For it to work, you need a non-regression criteria. So obviously, the higher quality your regression criteria, the better it will work. And the different kinds of regression criteria you can have are tests, but also compilation, which will give you a lot of insights very early. But it can also be the eyes of your teammates, reviews, mobs, pairs, all this kind of stuff. Smoke tests like I just used. And let's see how this works. So the Mikado method, it's a bit like an algorithm. And that's the nice thing with it, because it keeps you on track of what you're doing. So the first step is to try to do your change and to check for regressions. You can try trivial fixes, what we call scratch refactoring, to try to understand better what's going on, what's missing, what you need to do. And if at that point your non-regression passes, it means you can commit. And if ever you were dealing with your end goal, it means you're done. Otherwise, doing this scratch refactoring, you should have understood the prerequisites you need to do before you can move on. And at that point, once you've drawn these prerequisites on your graph, you can revert. I mean, really git revert. And so you get back to a green state. But the nice thing is that you can recurse this on your prerequisites. And that's how you build your graph, and you always stay in a green state. And this is what I'm going to demo right now. So first thing I want to do is, now that I'm a green state, is to commit. So git status. I'm just checking all this. Git commit. Here we go. What I'd like to do today, I'm going to do my change in a very silly way. This is what I'd like to do. I'd like to have my code like that. To get some insights about what's happening, I'll run the tests and see what's happening. No, I'm not running the test, it doesn't build, so I'm just checking the compilation errors. So I've got some errors because it doesn't know the player class. And then these arrays were deleted all over the place. Yeah, you see the undeclared identifier. It doesn't know the player class again. So here, yeah, I think it must be complaining, yeah, because player doesn't know the array, and so I'm gonna draw all this in a graph, and so I prepare the graph. Here is one. I'll hide this. So what my goal would be to replace the 4 collections with a vector of player. And from what I read in the errors, here is how I'm going to attack this. So first, I'm going to change type of players to a vector of player. That's the first step I'm going to do. Once I've done this, I'll remove the places array. And to do this, I'll need to add everything that's needed inside this one. And same thing for remove the versus array and remove the in penalty box array. So remember the algorithm, we've got this. So next step is to revert. Here we go. I reverted everything. Yes. I've got these arrays back. I should be able to build and even to run the tests. So what I'm going to try to do now is to replace the first step which was change the type of players to effective player. So this is, I'm just trying this. And I'm trying to build. Again, many errors. Let's see what's happening. So yeah, it doesn't know this real time. So here I'm going to do a bit of scratch refactoring. So I'm going to do as if I had a player class. It's really easy to declare this in C++, and this makes this field happy, and I should get more insightful error messages. Here is what I get. So I'm trying to add a player with its name in this array. I'm trying to plus something. What is this? So here I'm trying to print this player to the output stream. So and these, all of these are the same. And this one is, oh yeah, I'm trying to plus this basically it should be the string. So here there's a quick fix to just use this instead of the plus here. So I'm gonna write these down. So first step will be use instead of plus. This was at line 186, at 186. That's it. Another thing I did is that create a player class. And then something else I needed is that add a constructor to player with its name. And last thing I needed was to print player to, that's it. And so this one I could do it right now. Obviously, I'll need to create the player before I can do any of those. So this is what the first part of my graph looks like. So remember, I revert, I get back to green state, and I'll try the next step. So the next step is to remove the places array. So here is what I go. I delete this, I try to build. So places, it needs to be initialized, so this should be okay. So we've got here place is, it looks like the place is initialized to 0. Okay, so we could add this. So we'll need to add a place property to player. Initialize place to 0. What else? Here we're setting the place, getting the place. Here the same thing. Did you notice here? So this code here and this code here, they look very similar. So let me just first add player dot place and add player dot move to new place. So there seems to be a lot of duplicated things here, and I could actually add this to my graph, or I could even try to deal with that straight away, but this is actually a trap. So what I'm going to do instead, I'm going to use the parking technique. So parking, and I'll say something like Factorize code in, what was the method? I think it was in the role method. In role method. Why so? Because this is not required for this goal. It's something optional I could do to improve the code further. But if I start to put my finger in this, this is how you get caught up in refactoring, and that never ends. So if we want to stick to this goal for the moment, let's put this aside. And if ever at the end we've got more time, or maybe sometime later, we can deal with this. And other things, getters again. Getters, okay. So next step, get checkout. I could go on and build the graph for the two others, but I'm not going to do this right now because we wouldn't have the time to. What I'm going to do instead is I'm going to start to deal with these tests, with these steps. I mean, sorry. So here I need the player class as well, so I can add a link to there. But what it means is that I need to start with these first. So this one is very easy to deal with, and I'm gonna do this right now. So just do that. I'll run my tests. Okay, so it's passing, which means that I can cross this in. I can cross this in this graph, and I can also commit. And I think I'm going to increase the size of that a bit. Here we go. And so this step is done. So let's move to the next step we could do. So create a player class. So this is really easy. Add a constructor to player with its name and print the player to inferior. What I'm going to do is I'm going to write some tests, some TDD tests with that. And that's the nice thing with this, is that I can actually test this code right now. So instead of this sample test, I'm going to use a player test, and I'm going to say that player test can, or just prints its name. And so the test here is what the test would look like. Sorry for this. Is I'm going to create a player. I'll call him Joe. Here we go. And then I'll have string stream out. I'm going to output my Joe to this stream, and I'm going to check that Joe is printed from here, out.str. So this doesn't work, obviously, because there's no player class for the moment. So let's add one. Add class. So the class will be player. So this. Yeah, sorry for this C++ stuff. So this is coming every time I press escape, actually. So now that we're back in the text tests, where is it? Unit tests. Here we go. So I'll include this. And so it's complaining that I don't have a constructor and that I don't have this operator. So let's see if this can, if I can change this for some way. No, so I'm gonna add a constructor. Sometimes the refactoring tool helps you, sometimes not so much. So I'm giving a name here. Include string. Tag. Here we have. So this is working already a bit better. And the test is only complaining to you. I don't think you'll know how to generate this. And I usually look into Stack Overflow to do this. Here we go. This is it. So and I'm taking a player. I need to declare this in the H file. And I think my test should compile now. Yes, it does. So let's run it. And it's complaining because instead of Joe, I get nothing. So this shouldn't be too problematic to fix. So the first thing I need to do is to put the name as a variable. That's it. I'm going to store this in the, yeah, sorry, it's the name. That's it. And then what I'd like to do here is to have something like player.name. So in C++, this is the typical way to declare this operator. You declare it outside of the class, but then you don't see the private members. So in order to work around this, we usually make them friends. Friend things can access private things in classes. And this way, this should work. That's it. Which means that now I should be able to run my tests and hopefully have it working. Here we are. So if I look at my test, I've got a player class. I can initialize it with its name, and I can print it to an output. So if I go back here, it means that this is done. This is done as well. And this is done as well, which means that I should be able to tackle this one now. So first thing, remember, I'm going to commit. So we've got a player class with name. And let's try this one then. So let's try this one. Instead of this, I'm going to use player. It's going to suggest to include player there. And let's see, that seems to be building. So let's try to run the test directly. And it's passing. Great. We're actually benefiting from C++ default constructor call here, so that's fine for us. So let's make this okay as well. So it's more change type of game.players to vector of player. And that's it. So now it's time to move to the next things. So add player place. What did we have? Add a place property to player, initialize place to 0, add player move to. So again, I'm going to use TDD to do this. What I'd like to do is starts at 0. So I've got a Joe, and what I'm going to do is that Joe.place should be 0. So place doesn't exist. I'm going to add this int place const. I'll generate the implementation, and I'll first make sure this fails. Yeah, it's running. And once I know it's failing, I'm going to run it again and making it pass. So I'm going to go a bit, skip over this, and I'll make sure that a player can move. So I've got Joe dot move to 5, and this should be 5. So I'll need to generate this member function, move to void. It's going to be a new place. That's it. I'm going to generate the implementation. And what I'll need to do here is that I'll need to create a field for this place. So I'm going to int place there. I'm going to initialize this place to 0. Why is it complaining? Oh yeah. Place. I'm going to use. It's getting. You can't make the difference between the field and the method. Here equals new place. That's it. And hopefully with this, the test should be passing. Great. So it prints its name. It's passing. So it means that we've got this. We've got this one as well. It's initialized to 0. And we can move it. Which means that we should be able to tackle this. So the first step will be to player has a place. I can commit this and try to tackle this one. So, and this is going to be my last refactoring step today. I'll do this, try to build. So I've got a lot of problems, obviously. So first, this one, we don't need this anymore. This one here, we're initializing the players at this position. It's already done, so we can delete this. So here, what's happening here? We're doing a lot of get and sets of the place. So what we need to do first is to extract. We actually need to extract, or we could replace all these by players at current player then place. So what we're going to do instead is to extract a variable. Don't know if this works actually. Introduce variable. Yeah, I'll replace all the occurrences. Go to player. So I've got a player. And what I'm going to do instead, I'm going to replace most of these with player.place. So this one I can replace, this one as well. Not this one I can, this one I can as well. Not this one I can. I'm replacing all the getters. I'm leaving the setters out. So, and instead here, I'm going to do player.move to same thing here, same duplicated code we spotted earlier on. And what have we got here? So here we have players dot place, and yeah, it looks like we're done. And it's passing, which means that this step is done. So we could go on and continue on all the different steps, but we won't do this today. We don't have the time. Just a quick wrap up on the Mikado methods and its takeaway. So the main thing is that it's way less risky than tackling all the refactoring in a large big bang. Another side effect of this is that you can actually cut your refactoring in so small parts that you don't need to ask for permission. So if you cut it in very small part, just do a bit every day, and no one will bother you about what are you doing now. Another interesting thing is that the graph itself can be useful as a communication tool. So if you're co-located, which might not be the case currently, but if you were co-located, you could stick this graph on the wall. If we're remote, we'll need to find a different way. But what I mean is that different people can collaborate on different branches of the graph in parallel. Another interesting thing we saw is that compilation issues allow you to build the graph upfront. On the other side, runtime issues, so the more will extend your graph as you go. So if, for example, you find that a test is failing later on, you didn't spot this upfront with compilation, so you will need to extend your graph. It's not really a problem because at any stage you can still integrate, submit, and all. And if ever you fall on a problem, you just roll back to your last commit, and that's fine. And so the Mikado takes a different flavor if you're using a very statically typed languages like C++ and versus very dynamic languages like JavaScript or Ruby. A few other ideas is that Linus law, given if enough eyeballs, all bugs are shallow, which means that if you use pair or mob, you can find more bugs upfront, and so you can use the collective wisdom as a kind of non-regression criteria. And you can even use the Mikado method to set up your golden master test in the beginning. So that's an interesting thing when you're really stuck from the beginning. That's all for today. I think we're almost on time. So if you've got some questions, I'm willing to answer now or whenever.
That's amazing. Thank you very much, Philippe. That was a very cool talk. So unfortunately, we cannot hear the people clapping, but yeah, I can tell you that it was really interesting to see you do that, apply these techniques on a concrete code. That was great. I particularly like the parking methods because that's a typical problem you have. You're working and you think about plenty of refactorings you can do, and you can go in a rabbit hole. So that parking lot where you put your ideas, get off your head is amazing. We do have, we can take 1 or 2 minutes before the break to ask you the questions. So Christophe has a question, which is the operator you introduced. Was it needed for the player class, or did you write it only for the sake of testing?
The operator, you mean inferior? Yeah. So no, it was required because actually, when you look at the code in the game, it's used all over the place here. So in the code itself, it was already it was a string and it was dumped to the stream. And so we could have, every time this was called, we could have called the .name method in the player. But it involved less changes to just add the operator. So that's the thing.
Yeah, I think that answers the question. Thank you very much for your time. And now we're about to take a 10 minutes break. And next it will be Anna Felina, who's going to share her experience on working with very old code bases. Thank you very much, Philippe.
Thank you very much.